Hi, this is Kevin Trainer. Welcome to my lecture on use cases and use case diagrams. Now this is going with Chapter 7, Appendix A from the Hoffer Modern Systems Analysis and Design 7th edition. And I just want to point out that use cases are a very, very popular tool in practice today for documenting the requirements for an automated information system. And there's a lot of consensus on that, right? And there is some amount of consensus on the standards for creating use cases. In particular, the diagrams we're going to learn about in the lecture today, they're part of the UML standard. So they're pretty standardized. However, there's a lot of interpretation about how to use use cases. And even in the material that we're going to cover in this chapter from the brief appendix, some of it's a little different from the slant that I'm going to give you. So I ask you to be tolerant of that, okay? As we go through the material related to use cases, I think I'll try to point out where everybody agrees, where there's some disagreement, and the approach that I would like you to take in this course. Okay, so here we are. We're on use cases, and we've gotten here. The thing we did right before this was context diagrams. And these are two different approaches to documenting the requirements in the course of systems analysis work. The context diagram comes from data flow diagramming, also called structured analysis. And it was, it really started in the 1970s. So it's been around for a long time. It's mostly process oriented. And by contrast, the use case approach has really grown out of some work that's been done as part of object-oriented analysis and design, which is related to object-oriented programming. And object-oriented programming really didn't really get a lot of following until maybe the 1990s. And it's been very popular in the early 21st century and is popular today. Now these two approaches are very similar in a lot of ways. For instance, they are both great ways to describe at a high level who are the players who interact with our system and what kind of interaction do they have with it, what kind of functionality is exposed to the users of the system. You can tell that by looking at a use case diagram. You can tell that by looking at a context diagram. There's a departure though. Okay, so last week when we were doing context diagrams, we were very interested in data flow. Okay, so because the data flow approach, it's very process oriented. It was just the sort of the approach of the day in the 1970s. And so for instance, we identify the system in that central process that we put on the context diagram. we identify the external entities. These are the user types that are going to interact with our system. And then the way that we represent the interaction is that we show the data flows going back and forth. And from the names of the data flows going back and forth, you can infer what the functions of the system are. Now, if you want to know more specifically what the functions of the system are, and you had done a complete set of data flow diagrams, something that we don't do in this course, you could go to the lower level diagrams and you could say, oh, what functionality are these data flows attached to? And you could maybe get a clear idea of the context in which they're happening. Well, we're taking a different approach in use cases and use case diagrams, and I'll try to point out the differences as we go through the slides. So I'm not going to talk about the learning objectives. I am going to talk about use cases. So a use case is a depiction of a system's behavior or functionality under various conditions as the system responds to requests from users. We identify on the diagram actors. So these actors are external entities that interact with the system. So external entities, actors, very close corollaries between the two. Okay? Here's a picture of a use case, a diagram. Unfortunately for us, this one's kind of schmaltzed up with some features that we're not going to be using. Okay? So for instance, let's look at this diagram, and I'll talk about the parts that we are going to be using. Around the outside, you see 4 stick figures. These are actors. Okay, so these are like external entities from the data flow diagramming world, except that it's clearer that what we're trying to capture here in identifying these are the roles that are played in interacting with our system. Now, external entities on data flow diagrams can be organized into organizational units. So you could show the payroll department, you could show the warehouse, you could show all those kinds of things. As I taught you the methodology, I kind of steered you in a role-oriented kind of way because I knew we were coming here. And this is the point of view that I think is really most favored these days. So it's entirely possible that you could get here and have a one-to-one correspondence between the roles that you identify that interact with the system and the external entities that you had in your data flow diagram. Okay? Except that the rules for external entities in data flow diagrams are much more fluid than the roles for the actors in the use cases. In the use cases, very much we're trying to identify the role. We're not trying to identify a person, so we don't want to identify an individual name. We don't want to identify a job title. We want to identify a role. So here we're saying in this use case diagram for a university registration system, we've got 4 roles: student, registration clerk, instructor, and bursar's office. Now I've got to say that student is a great name for an actor. Registration clerk kind of sounds like a job title, but it is certainly a role that somebody could play, so I'm okay with that. Instructor, a great name for a role. Bursar's office, no, I don't like that. That sounds like the kind of name that we might have given to an external entity in a data flow diagram. So instead of bursar's office, I probably would say something like maybe billing clerk or billing agent or something like that that describes the role of a person who's responsible for billing, right? So three actor names here on the diagram that I like a lot. One that I don't like I don't like quite so much, and I have suggested an alternative. Okay, as we move in from the stick figures, there's a rectangular outline of the shaded area that we see on the slide, a dark blue line. We call that the system boundary. This is what shows the boundary between the system and the users of the system. So the functions in the part of use cases, which are those little egg-shaped or elliptical shapes named register for classes, bill student, etc. Those are inside the system. They're the functions that make up the system. And then, of course, the actors are outside the system. Okay, so that line that goes around that contains all the use cases is called the system boundary. All right, sometimes referred to as the boundary box. Okay, use cases, again, are these egg-shaped or oval elliptical shapes. And they have a name, okay, and the name is typically a verb-noun phrase. Enter orders, register for classes, bill student. It's something like that. So it's a verb-noun phrase, okay? Whereas the actor names are usually nouns or noun phrases. Okay. Now, look at the lines that connect the actors to the use cases. So there's one between student and register for classes. There's one between registration clerk and register for classes, instructor and register for a special class. And I'll talk about that special class thing before. That's part of the fancy stuff that I'm not going to be having you use because in my experience it doesn't add a lot of value at this point in learning about use cases. Okay, so this line is a connection between a use case and an actor. That's all that it says. Okay, so for instance, from that line we don't know what role they play in the use case. So the use case is typically thought of as a narrative of the functions that go on in order to help the users get their job done. So we have a narrative that we're eventually going to write that's going to be associated with register for classes. If we went and read the narrative, which is going to be in a specification, we're not going to learn that until the next unit of the class. But if we read the narrative in the specification, we would see that it involves the student and the registration clerk. And if you want to know in what order they get involved or what they do in interacting with the system, you can't tell from the diagram. The only thing you can tell from that line on the diagram is that they're involved. So if you go to the specification for the register for classes use case, that you're going to see some actions from the student and some actions from the registration clerk. Now, it's really easy for people who got introduced to data flow diagrams recently to think, well, there's data flowing between the student and the register for classes use case. And incidentally, that's probably true. I mean, how do we interact with systems? In the data flow diagrams, we represent that by showing the data flowing. Okay? Here, there is a data flowing, but that's not what that line means. The line means if you look at the specification for register for classes, you'll see that the student is involved in that activity. You'll see that the registration clerk is involved in that activity. There's no even implication about what kinds of data flows back and forth between the student in the system or the registration clerk in the system. So don't read too much into the lines. Okay, so you can see that, for instance, in the use case bill student, the actors involved are student and bursar's office. In the use case register for classes, it's student and registration clerk. And that's all you can really tell from a use case diagram, okay? Use case diagrams are really good for being able to explain to people what functionalities in the system, because the names of the use cases usually do a pretty good job of explaining what functions live in the system. And then who interacts with which other functions, and you can see that by the connections between the actors in the use cases. But that's all you can tell. If you want to know more, you need to delve in and you need to read a specification associated with the use case. And we're going to learn how to do those in the next of the units. Excuse me. So, what's involved in these two use cases that are connected to register for classes? It says that they extend register for classes. Register for special class, identify prerequisite courses not completed. So people who are using this use case approach in a fairly sophisticated way, they like this idea that there are relationships between use cases. Okay, and so one of the relationships that they can have to each other is one extends the other. And we'll see eventually that the other relationship is includes. Martin Fowler, who is a writer, soothsayer, general smart guy about all kinds of things having to do with information technology and systems analysis and design. He believes that this feature where we can have relationships between the use cases is the place where people get the most kind of fouled up when they're just learning to use the use cases. And he believes that we don't need that when we're beginners. And I follow his advice on this wholeheartedly. So I'll show you the notation for relationships between the use cases, but I'm going to counsel you against actually using it because at this point in your career, you are definitely a beginner at use cases. All right, let's move on. So let's see, most actors represent user roles, but actors can also be external systems. So in the same sense that back in the context diagram, one of those external entities could be another system that interacts with ours, okay, and is in a sense a user of our system. The same thing with actors here. Now, if we have an external system that is an actor, we can use this same old stick figure to represent that, system. So let's say it's a credit card processing system. We would just have a stick figure, and it would say credit card processing system. That's all it would say. There are some diagrammers that have a special symbol for system-based actors. I don't think that adds a lot, so I'm going to expect you to be using a stick figure to represent a human actor or a system actor. Okay. An actor is a role, not a specific user. One user may play many roles, and an actor may represent many users. A use case model, which is what we're going to build, consists of actors and use cases. And a complete use case model includes also the specifications that accompany the actors in the use cases and the diagrams. Okay, so a use case diagram is a picture showing system behavior along with the key actors that interact with the system. Well, we just saw that before. What's an abstract use case? Well, this is another kind of fancy feature of use cases that on the advice of Martin Fowler and in the experience of Kevin Trainor, is not really a good thing for us to go into. So we're not going to be dealing with abstract use cases. A use case represents complete functionality. Well, what do we mean by that? Well, typically, if we go back to the diagram, what we're trying to do is that we're trying to identify a unit of work that is sufficiently substantial such that it represents a real kind of job for the actors at hand. So, interesting. I see a thing. I've got one thing that I would change on this diagram. The name of the top process, the top use case is register for classes. I always teach that the nouns in a use case name are normally going to be singular because what we want is one cycle of the user activity. So what's that? Well, we register for a class. Okay. So now maybe in this system you have to register for all your classes at the same time. It's all or nothing, in which case register for classes would be a great description of it. So it's a question of how it really works, I guess. But if you can register for one class at a time, register for class would be a better name. But a judge if we've picked our use cases the right way is if we go and look in the student and we say, register for class, is this a significant job that the student has to get done? Yeah. What about the registration clerk? Yeah. Okay. So that's a good choice. A bad choice would be something like enter user ID. Okay. It's certainly action. All right. It certainly has to go on, but it's not significant in terms of a whole job getting done for one of the actors. So we want these things to be aggregated enough that each of the use cases represents a significant user goal. On the other hand, we don't want them to be so aggregated that it becomes hard to write the specifications because they have so much activity inside them. Okay, so here are the symbols. So the use case is an ellipse or oval. The actor is a stick figure, and you'll see in some of the diagrammers that they're not quite stick figures. They look like the outline figures you'll see on the outside of bathroom doors for men and women. We have the boundary box that goes around all the use cases that are shown in the diagram. We have the connection line, just a plain line, no arrowheads at either end. And then we have these two relationships. We have one called include and the other called extend. And they have a line with some text on it. And those two sets of angle brackets are called guillemets. Okay? Spelled guillemets. And the whole bit of text here is called a stereotype. So this is a way to take a normal connection and say it has a special character. It has the character of include and extend. And proper include lines and extend lines have an arrowhead on one end. But I'm not going to do a lot of training on that because I really would like you to not be using include and extend. It's the kind of thing you could learn in a sort of a second round of training on use cases after you're successful at the current round. We've already said an actor is a role, not an individual. It's involved with the functioning of the system at some basic level, represented by stick figures. A use case represents a single system function, represented not as an ellipse, as the author of the slide accidentally typed, but ellipse. The system boundary includes all the relevant use cases. So you can think of the boundary as kind of almost an aquarium tank in which all these use cases are contained. And a lot of times I'd like to think of the functionality that goes into the system as being like water. And I'd like to think of those ellipses as kind of like water balloons, because if you filled them up and you sat them down, they would kind of take on that shape. And you could put, the water balloons in an aquarium or a terrarium or something like that, and that would contain them. So a boundary is a dividing line between the system and its environment. Use cases are inside the boundary. Actors are outside of the boundary, and the boundary is a box, a rectangle. Now, I can't emphasize this enough. The system itself is not an actor. Okay? Yeah, we did say that sometimes systems can be actors, but that's not our system. Okay? There are a lot of systems around, and a lot of them interact with each other. So our system is represented in a use case diagram by the sum of the use cases that are inside the boundary box. Okay? That's all the functionality that's in the system. That's our system. Okay? The only systems that can appear on the use case diagrams as actors are somebody else's system. Something like a credit card authorization system, or maybe some kind of a banking system, or something like that. Okay? The connection we talked about already, that's the line that goes between the actor and a use case. It depicts a usage relationship. It does not indicate data flow. Okay? That's where people just get sucked down the data flow path. Actors are connected to use cases with lines. Use cases are only connected to each other when we're using those use case relationships, which we're not. So the last of the bullets here we're going to say is not something that we're going to do. So, which means I'm not going to give a lot of airtime to the extend relationship. I'll leave you to read on that on your own, because I want to talk you out of actually doing it. Or the include. Okay, the way we're going to learn to do these, we're not going to have to use extend or include. It turns out that there are features of use case specifications that allow us to represent the same kind of information about the system without having to resort to this kind of relationship. Okay, so if we were to use the relationship types, they would look like that, but we're not gonna, so don't. Now, written use cases are the specifications, okay? And we're going to deal with that in the next unit. But it's kind of nice to know what kind of stuff is in them so you kind of understand, because we just get a high-level view from the diagram, okay? So a written use case, or what I call a use case specification, is a document that contains the detailed specifications for a use case. The contents can be written as simple text or in a specified format. In most organizations, they have an agreed to format, and they have a word processing template that they follow, and that's what we're going to do in this course. And it's a step-by-step narrative description of what must occur in a successful use case. So there's a couple of elements there. Step-by-step narrative description. So there's a narrative. It tells a story. Okay. Most user requirements documentation approaches these days involve stories. In agile development, they have these things called user stories. In interaction design, we have user scenarios. Here in this technology, we have use cases. So we have a narrative story, okay? And there's also a very big emphasis on trying to describe the successful use case. So we try to have information in there about what can go wrong, but the general emphasis is on what happens when everything goes correctly. Oh, here is what the authors think it would be the nice kind of big divisions in a written use case specification. They have a title, primary actor, level, stakeholders, precondition, blah, 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 blah. We're going to do ours a little different than this. We're going to be following a format that has been popularized by IBM that I like a lot and I've done a lot of work with. Okay, and we'll be getting to that when we get to the next unit in the course. There are people who believe that you have levels of use case. Okay, so, and this is a very popular idea. It's not one that we're going to be using in our course. Okay, so we're going to come up with one sort of level of use case. Okay, and we're not going to have some that are at a high level and some that are a low level and all that kind of stuff. We're just going to come up with a series of use cases that are kind of mid-level, and we're going to see that as I do the tutorial video demonstrations. I think you'll get an idea about how summarized or how detailed we want our use cases to be. So we're not going to even fool with this level of use case idea. Here we have a format for the use cases, and again, we're going to have our own format. So I'm showing you these as a way to get an idea of what's coming along. Okay, so there's a lot of There's a lot of information here about a use case. And again, it's a combination of the general style, and you can kind of see for that from what's on slide 20 here, is that it's a specification, so it's narrative oriented, but we have a lot of lists of things and such, so it's not overly prosaic. And essentially, we're trying to describe what happens in the use case when things go according to plan. And then we have other things where we talk about what can go wrong and all that kind of stuff. So, we've talked about use cases and where we're going to go to from here is we're going to go and do a tutorial video where we're going to do a use case diagram for kind of my sample problem, which is the student attendance system that's becoming my sample case for a lot of things. So I don't have a lot more to add here. I'm going to say goodbye here, and I'll see you next time. Bye-bye.